My little Elmo device isn't working. Normally I would do less notes like this at the board, but I don't have that nice color addition calculator at the board, so I'll sit down and do them. So these are the notes for Tuesday, because a lot of you guys will be on a field trip. So they're getting posted in advance. It's a solve by graphing, and this is absolute value. First off, you do have to realize this is absolute value. Which I know there's a lot of y'all that don't, but anyways, absolute value starts with the letters ABS. All right, simple enough. You're going to go to Math, and then you're going to scroll over to Num, which is exactly how you feel in my class. And the first thing that is there is ABS. So in Y1, and if you have an older calculator, it actually shows up ABS. The newer ones, they show the bars. And I'm talking about this whole Y1, Y2 thing. That's what we do. We put this in Y1 and we put this in Y2, but we haven't, that's not a first for y'all. In Y2, we're going to put 2x minus 1. So let me walk you through that. And I'm going to try and keep these videos short. So I'm just going to do this stuff. I'm not going to do any of the you try stuff. Okay. Go to Y equals, Math, roll over to Num, ABS. See how it is, ABS? I just forgot the parentheses there. It's supposed to be parentheses. And the newer calculators have the bars. So x to the second minus 4x, and then 2x minus a 1. And then I just hit a zoom 6. You always zoom 6. And you can tell you're going to have to play with your window. You're going to have to look up a little bit to see this intersection right here. So I'm going to adjust my Y max. I'm going to set it to 20. That ought to do the job. And then I should see both intersections. And that's the goal. All right. We've used the intersection feature in here before in the past. We're going to hit second trace. So second trace, and we're just going to scroll to intersect. And to use the intersect feature, you get the cursor close, and then you just press enter 3 times. You know, if you need that note, hit the pause key, whatever. But it's not a hard skill. So I get close. Looks like there's an intersection right there. I'm going to get close to it. I'm going to press enter, enter, enter. And on your test, I'll either take this out to the 4th decimal or 4 significant figures, but I really need to be teaching y'all significant figures, but I also need to teach you how to round too, so I'm kind of tore up on that. But anyways, x is 2.4142. There's one of them. And there's another one, right? There's one right here. Second trace 5. Do it again. Get that little cursor close. And once it's close, you're going to press enter, enter, enter. There's the other one, 5.824. 8284. I said that wrong. 5.8284. All right. So I'm not going to do the you try. Keep this video short. Solve a linear system by graphing again, and you are literally pressing y equals. So that means that these equations must be solved for y. There's only a handful of y'all that can't do that, but it's not a hard skill, is it? So I'm going to look at this guy first. 2x minus 3y is 12. I'm going to jump my 2x over. Negative 3y is negative 2x plus 12. Then I'm going to divide by a negative 3. And I get that y is a positive 2/3 x minus 4. Now, the truth is, if you're one of those kids who doesn't know what negative 2 over negative 3 is, or what 12 divided by negative 3 is, you can type it in. You can actually just throw this at the calculator. I'll judge you for it, but you'll get the answer right. All right, the other equation needs to be modified as 7x plus 2y is 24. So the 7x moves over. And since you're using technology, honestly, the order doesn't matter. 2y is negative 7x plus 24. Divide out the 2. And again, if you don't know what 24 over 2 is, don't worry about it. In fact, I'll even show you that. But I'm going to simplify it. Now, what you should put into y1 is this. But I know there's some of y'all that struggle with breathing alone. Bad joke, right? But if I don't know what negative 2 divided by negative 3 is, I can just do negative 2 over negative 3. And the calculator will figure it out. And if I don't know what 12 over 3 is, I can literally type 12 divided by negative 3. The calculator will not judge you. It's not me. Okay? But anyways, I'm going to type the next one in right. You do have access to fractions if you want to use them. You can hit Math, Num, and it's right there at the bottom of the list. I actually hit the up arrow, but it's right there. It's choice D. So say you like things pretty, you can use the fraction key. Anyways, those are the equations. Zoom 6, as always. Two lines can only intersect once, unless they're the same line. And there's the intersection. Second trace 5, get close, enter, enter, enter. Enter, enter, enter. There's your intersection. You don't have to round this one. It's exactly 3.84. That's what x is. So, half done with the notes. Moving on to the back side of the notes. There's two more to go. There's a solved polynomial. By the way, how many total solutions does this guy have? The exponent is 5. It will have 5, 3, or 1 real. Will they all be real? No. But I could have upwards of 5. The reason I said 5, 3, or 1 is because that's an odd exponent. There will be 5, 3, or 1 real solution. The other ones might be imaginary. Sorry. That needs to go there. Since the highest exponent is odd, there will be 5, 3, or 1 real. Even though I'm not going to do the U-try, I'm going to talk about what that exponent means. But this one's real simple. Place the left-hand side into y1. Place the right-hand side into y2. And do a zoom 6. That's all there is to it. I know one of the issues is a lot of y'all don't have calculators. It's always been an issue. The librarian, although she's not here, but I think the substitute librarian can probably still check them out. I mean, she has them. Anyway, zoom 6. I can't give them to you. You'll never give them back. There's two answers. There's one here and one here. This problem actually lends itself nice into, and you might do this, but you might zoom in. So zoom in, it's choice 2. And what you do is you get your cursor closer, just zooming in on it. So I'm going to put my cursor right smack dab in the middle of those two intersections. Then I'm going to press enter. And I get a closer picture. There's obviously two solutions, one there, one there. There's a third one. We're going to have to go hunt for that thing in a second. There's supposed to be 5, 3, or 1. Second trace 5 for intersect. Enter, enter, enter. So one of the x values is 0.3811. Second trace 5. I'm glad I did this in the video. I don't know if I'd have caught that in class up at the board. I get a little disoriented up there. 0.9525. Now back to this. This is how rule things work when it comes to exponents. You take the highest power, you subtract by 2, and that tells you how many are real. So this one has 5, 3, or 1 real. 2 is not going to cut it. There's got to be one more. I don't know if you notice it, but this thing is starting to flatline. I think there's one way down there. I'm going to adjust the y min on down to negative 500. That was too much, actually. Did negative 50 do it? Yep, there it is. So I actually made an adjustment. My y min I set to be negative 50. I might need to go back and look at the twin work I did. Yeah, I'll check it later. Second trace 5 for intersect, or maybe I won't. Who knows? But there's a decent chance I forgot about that when I was doing it. Get close, enter, enter, enter. Negative 1.2260. There's the last one. Now, I'm not actually going to do this U-try, but we are going to talk about it. It has 8 total solutions. 6. That's a 6. The highest exponent's a 6. Because it has a highest exponent of 6, it has 6, 4, 2, or 0 real solutions. I stopped at 1 here because if you take 2 more away, you're at negative 1. There's no such thing as negative 1 solutions. But you decrease the exponent by 2 for the real solutions. And that one could be anything. All right? Solve this dude by graphing. This is an inequality. And this happens to be a quadratic. And this happens to be a line. And what we're actually asking is, where is the quadratic above the line? Unless you're doing a bonus question on your upcoming quiz, I don't care if you do intervals or if you use inequalities. I will do both. 5x to the second plus 4x y1, and then 7x minus 2 y2. So zoom 6 it. Sugared up. Somebody hasn't verified their problems here. Let's change that to a plus before you guys run across these notes tomorrow. There was nothing going on. In fact, let me make this quite a bit different. Let's do 7x plus 5. I think that'll give me an answer I want. So I changed the problem if you're watching the notes for the first time. All right, so where is the parabola above the line? You don't have full picture, but here for sure, okay? We'll look up a little bit. Y max to 20. There we go. Here, as I move left, and here, as I move up. So there's 2 intervals there. One on the left, one on the right. I hope you see that. I'm going to hit second trace, intersect, get close, enter 3 times. And one of them is so long as x is less than negative 0.7440, because I'm moving left, and this is true. So x is getting smaller, hence x is less than. The other one happens on the right. Second trace 5, take my little cursor, get him close, enter, enter, enter. And as long as I move right from here on, the parabola is above, greater than 1.3440. Now, if you don't like inequalities, you can write interval. This one right here is equivalent to negative infinity to negative 0.7440. And the reason I went 4 decimal places is because that's how I'm going to do these, 4 decimal places. Union with the other inequality, 1.3440 to positive infinity. And I don't really have a preference which one you're doing. If you like these, do these. If you like these, do these. I don't really care. Really don't. And that is day 1. Hopefully, well, a lot of y'all will be on a field trip tomorrow, but anyways, that's day 1. Only 2 days of instruction on this.